So here are the notes for 15.6 and 15.7. Today we're going to be talking about quadrilaterals. We've done a lot of talk about triangles, and now we're going to expand on that along with the parallel lines to get to quadrilaterals. And so we have these four unique figures here: a parallelogram, a rectangle, a rhombus, and a square. So we're going to talk about the different properties of each one and what makes a shape one of or some of these four. So the first one is parallelograms. So this is properties of a parallelograms. This happens for any type of parallelogram, and that is that opposite sides are parallel, opposite angles are congruent, and diagonals always bisect each other. So that happens for a parallelogram. And again, the big thing with parallelograms, right, is that we have two sets of parallel sides. And so without those, it's impossible to have a parallelogram. And not only are the opposite sides parallel, but they are also congruent. Okay, and that's going to be a big recurring theme here throughout all of these shapes, is that those characteristics continue on for all of those. Okay, so opposite sides are congruent, opposite angles are congruent, and your diagonals will bisect each other. Again, meaning bisect that they cut in half. Half with an A. And so for number 4, it says ABCD is a parallelogram, find each measure. And so we know that opposite sides have to be congruent. So those are two opposite sides. And so you'll see that the first side, BC, is 5x plus 19. Second side, AD, is 7x. So we know that BC has to equal AD. And therefore, 5x plus 19 has to equal 7x. So now we can solve for x. We're going to subtract 5x on both sides. So we have 19 equals 2x. Divide by 2. And so x equals 19 over 2. And so in order to find one of those, I just need to plug it back into only one of them. So we'll do AD because that one looks easier. So AD is 7 times that 19 over 2. 7 times 19 is 133 over 2. And this is an instance where it would be more okay to get a decimal. You could leave it with 13 or 133 over 2, and you would be totally right. If you want it to make maybe a little more sense as you're looking at it, 66.5 would be the answer there. And so again, that's for AD and BC, since they are both the same, right? Those opposite sides are congruent. Now we also have opposite angles here, angle B and angle D, and those have to be congruent. So angle B has to be equal to angle D. So 6y plus 5 has to equal 8y minus 17. We're going to subtract 6y from both sides. Move that over first. So we get 5 equals 2y minus 17. Add 17 to both sides. We get 22 equals 2y. last step, divide by 2. So y equals 11. And again, we want to know what those angles are, so we'll just pick one and substitute that back in. Angle B is 6y plus 5, so 6 times 11 plus 5 is 66 plus 5, or 71 degrees. And again, that's both angle B and angle D because they are opposite. Now the reflection question, question 5, says suppose you wanted to find the measures of the other angles of that parallelogram. So explain your steps. So we know that B and D are both 71 degrees. So I'm going to erase this. Maybe not. Let's try 71 degrees there, 71 degrees there. And we know that the outsides are 66.5. And so it says to find the other angles, right? So if we know two of the angles are 71, and we know that those opposite angles, angle A and angle C, have to be congruent, how would we maybe find those out? So I'm going to let you answer that, see kind of what you can write there, and about how we would find those two angles. And if you have a question, you can ask me about that tomorrow and I can clarify. And then numbers 6 and 7, PQRS is a parallelogram. Find each measure. So at this point, I am going to let you pause the video and try and work on numbers 6 and 7, and then I will explain in just a second. So to find QR, that is this side here, we should also notice that the opposite side would be PS, so those have to be congruent since it is a parallelogram. So 2z plus 4 has to equal 3z minus 4. And since those are equal to each other, we can simply solve for z. Subtract 2z on both sides. 4 equals 1z minus 4. So if we add 4 and add 4, z is equal to 8. And so QR was 3z minus 4. So QR equals 3 times 8 minus 4, which is 24 minus 4, or 20. And do we have any units there? No, we don't. So QR equals 20 would be our answer. And then we need to solve for PR. So I want to know what is that whole distance here. Well, we were told up above that our diagonals bisect each other, that they're cut in half. So I know that this top half, PT, is going to be the same as the bottom half, TR. So I know that PT is equal to TR. Well, I know what PT is. PT is x plus 9. That has to equal TR, which is 4x minus 6. And so again, we have an equation. We can now solve for x. 9 is equal to 3x minus 6. We can add 6 to both sides. So 15 equals 3x. Divide by 3, divide by 3. So 5 equals x. And if we substitute that back in, right, so for example, PT is 5 plus 9, which is 14. Now that's only PT, right? That's just this little section, this blue highlighted section right in here, right? That part right there. It's 14. So if PT is 14, TR then, right, that section right in here, is also going to be 14, which means that PR all the way across, PR is going to be 14 plus 14, or simply 28. Okay, so that one required you to remember that at the very end, right, we have two halves that we have to put together. So question 8, reflection question, JKLM is a parallelogram. Again, they don't give you a diagram, but it tells you that's the shape that it is. So name all of the congruent segments and the congruent angles in that figure, in figure JKLM. So I'm going to leave that for you to figure out. Tomorrow I'll kind of ask and see how you guys did on that. So we will move right along into 15.7, which is now talking about these other kind of subsets. Now the thing with parallelograms, right? Parallelograms is kind of the umbrella here. And so I like to think of parallelograms as fruits. Right? There are lots of different types of fruits that we can eat, right? You've got apples, bananas, oranges, grapes, watermelon, all kinds of stuff. But they're all still fruit at the end of the day. And so the next three things that we're going to be talking about, they're all those specific types of fruit. But again, they all share that same common bond of being a parallelogram. So a rectangle, right, would be, for example, let's say your apples. Right? So a rectangle is going to be your apples. And so they share all of the things that parallelograms do, but they have some specific things unique to them. And so for rectangles, again, your opposite sides are parallel, and your opposite sides are congruent. So those two things right there were from your parallelogram. So I'm going to put an asterisk by everything that carried over from parallelogram. And for a rectangle, all of your angles are congruent. Not just the opposite ones, but all of them. And again, they're all 90-degree angles. You probably knew that already. Consecutive angles are supplementary. And then diagonals bisect each other. There's another one that comes from our parallelograms. So diagonals bisect each other. And then also for a rectangle that's kind of unique is that the diagonals, not only do they bisect each other, but they are also congruent. So each diagonal is equal to the other diagonal. So in the case to the right here, that tells you that AC is congruent to BD. So that whole diagonal AC is congruent to the diagonal BD. So number 9, explain why this is a true condition for rectangles. If one angle is a right angle, then the parallelogram has to be a rectangle. So again, if we have a parallelogram and we know that we have one right angle, right? We know these two lines are parallel, and this is a transversal. So we have some same side interior angles, which we know are supplementary. So they have to add up to 180. Well, if one of them is 90, 180, minus 90 is 90, so that's going to be a 90-degree angle. And then we could also do the same thing going with GH and FE. And we have this transversal going here. Again, some same side interior angles. Do the same thing, 90 degrees, and then again, 90 degrees. Okay, so is that using that those properties we learned about parallel lines, right, or same side interior angles being supplementary to help us out there. And again, we have some deep thoughts here, right? All squares are rectangles, and we're going to get to squares in just a moment. So all squares are rectangles, but not all rectangles are squares. Okay, and that's hashtag deep right there. Okay, that's getting real. Okay, so similarly, right, we were talking about fruits earlier. right? It's like saying all fruits or all apples are fruits, but not all fruits are apples. Okay, so a rectangle is unique, and a square is a specific type of rectangle, but a square, again, also has its own special properties that we're going to get to in just a second. Now, before that, we have something called a rhombus, okay, a rhombus, and these are going to be our oranges, per se, right? So they're still technically a fruit, but they are, still its own unique food. So again, opposite sides are still parallel, which is one of our core ideas here, except now for a rhombus, all sides are actually congruent. So not just opposite sides, but all sides are congruent. Opposite angles are supplementary, yes, our opposite angles are congruent, Opposite angles are congruent, which was one of our parallelogram characteristics. Consecutive angles, again from the rectangles, they are still supplementary. Diagonals bisect each other. That's still from parallelograms. And the diagonals are actually perpendicular, which is special. So those meet at a 90-degree angle. And your diagonals in this case also bisect opposite angles. So if you look at the right diagram over on this side, you'll see that angle F and angle H have been bisected, right? Those two sides are completely cut in half by that diagonal. Now, I think this was a typo here. I apologize. Okay, opposite angles are congruent. They are not necessarily 90 degrees when it comes to a rhombus. Okay, that will change in just a second, but for a rhombus, okay, opposite angles are just congruent. They are not necessarily 90 degrees. So that is a rhombus. You'll notice there are some things that are very similar to that of rectangles, but and then there are some things that are kind of similar to squares, right? All sides being congruent. And so what a square, to me, I kind of think of a square as if a rectangle and a rhombus had a baby, it would probably be a square. Okay, it kind of combines aspects of both of those, and out comes a square. So we still have our parallelograms, which are all our fruits, right? And then we have some very specific ones. Our rectangles, which are apples, our rhombuses, which is our oranges, right? And they each still share those characteristics, right? You'll notice the blue asterisks on the left side here, but they are still unique in their own right. Now a square, okay, again, it's just another one of our fruits, right? This one I'll say is a banana, okay? Again, it's very unique, has its own characteristics, but it's still technically a parallelogram. So opposite sides are parallel and congruent, but in this case, something special about them is that all sides are congruent. We also know that all angles are congruent, in this case 90 degrees. Consecutive angles are still going to be supplementary. We know that diagonals, again, will still bisect each other. And we know that diagonals are perpendicular. Diagonals will bisect opposite angles. And that diagonals are congruent. So again, that's what I'm saying when it seems like a combination of rectangles and rhombuses. It just includes all of them. I mean, it's pretty much you take every property we've learned so far, put them into one shape, and that gives you a square. So for numbers 10, 11, 12, and 13, determine what type of quadrilateral it must be. Now, hopefully, you can kind of start to knock off some of your choices, right? We have a parallelogram, a rectangle, a rhombus, and a square. So you'll notice a square is not going to be ones with opposite sides, right? So that gives out 12 and 13, 11 and 10. 10 is the only one with right angles, so that must be a square. The only other one that has congruent sides is a rhombus, so number 11 must be a rhombus. Number 12 and 13, you'll notice 13 has some 90-degree angles, which you know have to happen with a rectangle, which means the last one, number 12, is just a basic parallelogram. Now for numbers 14 and 15, find the value of x that makes each parallelogram the given type. This is pointing towards this angle right here. Okay, so that's pointing towards the angle. And so if I want that to be a square, that angle needs to be 90 degrees. And so I'm going to have you set that up and then solve, and you can finish that one on your own. And again, a rhombus, right? All sides of a rhombus have to be congruent. So if that's the case, these two sides would have to equal each other. So I'm going to let you finish that one as well. And again, if you have any questions, you can ask me tomorrow in class. But that's pretty much it. For the most part, again, just being able to determine which ones are which. You don't need to necessarily know every single property per se for every single one. Just notice the big key differences in between the four in terms of how to verify which one is which.